I'm Peter Lyric and I'm with Nature Conservation Margaret River region, and we're here today. We're doing a Dealing with Dieback workshop, and we've got Jeremy from Great Southern Biologic who's going to come and give us some tangible strategies on how to identify and manage dieback in our properties and in our national parks. And it's all part of For Nature, the Landholder Stewardship Program. And to find out more, go to our website.
Look, first of all, really good to see such a bunch of, such a good number of faces here. I have also done dieback management over in Tasmania or in New South Wales as well. And in Tasmania, I was actually the program coordinator for the state's environmental education program. And my boss had this little saying that I usually get wrong, so bear with me if I do get it wrong. But through raising awareness, we develop an understanding within the community, and by getting that understanding going, we develop an appreciation of what we've got, and that develops support for the initiatives we try to implement to manage whatever issue it is. So I will try and deliver this sort of session to a range of knowledges and understandings to cover everything from raising awareness to developing understanding, with the objective of hopefully at the end of the day making sure, or hoping, that everyone is on board and can understand what it is that they can do in their own small or large enterprise environment sphere of influence to make sure that the risk of Phytophthora dieback, which I'm just now going to call dieback from now on, is mitigated. And just to give me a bit of an understanding, I've met a few of you before and I know a couple of people, but just quick show of hands if you're just sort of like a community resident with a small property. Yep, an representative of an organisation, a land manager that's got significant areas. Yep. Or from out of town or part of recreational groups, perhaps organised recreational groups, mountain bikers, board riders, clubs, that sort of stuff. Okay, no worries. So the structure of today is going to be a bit of sitting down. I'll prance around a bit. I'll get you to stand up, sit down again. It's all just sort of a bit of the play school act to keep us stop from not falling asleep. We'll have a look at what the disease is, where it's come from, what it does, because developing an understanding, a keen understanding of what the disease does and how it works is very important in understanding how we manage it in the past. So Phytophthora dieback, or dieback as I promised to call it, is what we call a water mould. Now, it's got a very similar life cycle to a fungus. So if we think of it in a fungus, and the primary concept I want you to get in your minds, in your heads, is that it likes it moist and warm. So we grow our mushrooms and all that sort of stuff often under the bed, so it also likes sunlight. So it's not a fungus. But it likes it moist and warm. So that's the environment within which we're operating. And in our environment, we look at sort of average temperatures between sort of 20 to 35 degrees is what we're terming warm, and moist is classified by rainfall zones, and we're working within typically the 600 rainfall zone and up. It can survive in the lower rainfall zones, but importantly for us here, we've got Cape Lewin down on the south of our region here, and that gets 1200 mils. And I think Cape Naturalist is up in the sort of, maybe 1,000 to 1,100, something like that. And moving into the hinterland, we're well and truly within the rainfall zone and the temperature zone for the disease to have a significant impact. And when you start to know what you're looking at, you really start to see how badly it's impacting our vegetation, and not just the vegetation, but the flow-on impacts. So the other thing that we need to understand is how it impacts things. So I'm a tree. I'm standing here, I've got my feet firmly planted in the soil. Underneath me, I've got my root system spreading out. Now a plant's root system is a little bit more like its hair. It sort of goes everywhere. My hair used to be much more like a root system than it is these days, but it spreads right out. And that is how the disease gets in from the soil. So it's a soil-borne pathogen. The disease is microscopic, so it's tiny, so it gets in and it's not impacting the roots that we sort of see as great big subterranean trunks. It's impacting the small fine feeder roots that we don't necessarily see. So the disease is in the soil, it's getting all around here, it's attacking my root system, breaking down the internal transport systems. Plants are just like us. They have a need for moisture, they have a need for nutrients in order to maintain a healthy lifestyle and keep them functioning really, really well. So they're extracting nutrients and moisture out of the soil, and when the sun's out, they're photosynthesizing and they're turning the solar energy into a range of complex carbohydrates and sugars, which is then pulled down through the leaves into the vascular tissue which is in the plant, which is the phloem and xylem, which is effectively a whole series of tube-like structures, almost like small straws, radiating up and down the inside of the stem of the tree. Now the woody plants that we've got all have xylem and phloem in vascular tissue just underneath the bark. It's called the cambium. And when the tree is transpiring, so when the sun's out, it's letting moisture out through its leaves and it's effectively pumping juice up from the bottom and transporting nutrients down from the top. So if the pathogen gets in and kills its root system, for a human being it's like having your throat cut and all of a sudden we're dead. Okay, I didn't sort of get a little bit ill and develop a cough and spend a week in bed and then get a bit better. I didn't sort of, lose a leg but managed to have it amputated and then suddenly was able to hop off and be quite fine, thank you very much. I keeled over and I died quite quickly. That's a very diagnostically important feature for recognising dieback, because we get a lot of other pathogens and just old age as well gets in and impacts the vegetation. So it's a very important factor to remember. That's what it's doing. It is also getting in and impacting the vegetation as a community. Now it spreads. Our plants, I'm standing here again as a tree and I've got my root system stretching out underground, and for those of you who've done botany and biology and have a bit of an understanding, quite often the natural plants, the plants will have a root system that's not dissimilar in expanse to their crowns. They'll stretch out metres, 10s, 20 metres from the base of the stem. So if I've got dieback in my root system and I'm growing out and I've got dieback infested, reach your arm out, pay attention, and then I will spread it out and I will infect Peter, and that's how it spreads naturally. So it's microscopic, we can't see the beast itself, it's spread in the soil and it impacts the tree's roots. And one of the things that makes it particularly nasty is that it has a two-stage life cycle. So when the environmental conditions are perfect, the little beast is active in the soil and it's producing zoospores. Now zoospores, to put them ignorantly, are pretty much like a microscopic tadpole, okay? They're actually mobile in the soil and they can move through by swimming. They've got a little flagella on the end of their, I thought you might have been disagreeing. I was going to say, yes, they do. They've got a little flagella and they can move, but they're microscopic. So a 100-metre sprint in the pool for a zoospore is not actually very fast. So they don't move by that method of spread very easily. And a plant's tree system is quite big compared to a tree and to where we're standing, but that autonomous spread, that's a term that we're going to use, like autonomous spread, which is the automatic spread of the disease, in its sort of natural environment, because it's an introduced pathogen, is very slow. It's a soil-borne pathogen. The biggest risk of disease movement is through me or you or any other human being getting hold of some infested dirt, which you're not going to go and do like this, because what you might do if you like the beach sand, but it's our vehicles, it's our equipment, and it's our machinery that we drive through bush tracks, bog holes, mud pits, mountain bikes, graders, those sorts of pieces of equipment that will get mud caked on their mud flaps and their wheels and their wheel arches and up in the suspension of their, various cars, and move it. What does mud do when it dries?
Cracks.
Shrinks, cracks, and falls off. That's right. So we can spread it hundreds of metres, if not kilometres at a time. So suddenly we start to see that great big method. Gotta give it a hand here, of disease spread. So we want to have a look at how the beast works and what it does, because, like I'm saying, this is just a bit of dieback we prepared earlier. It's in the soil. This is breaking edge. This is cutting edge. That's why this has never been done before, so it might not work and it might not be that impressive. But if it does, I want you all to go, ooh. So there's a dead tree. Look at that. And there's a live tree. Look at that. I've got them the wrong way around. So basically, it's the forces of what we call capillarity. I'm sure we've all heard that before. Of how the disease spreads. I don't know how we're going to do this. So basically the disease is introduced. It's not a natural pathogen. We brought it here. It came from the cinnamon fields of Malaysia is the most common thought. It's Phytophthora cinnamomai. Is the nasty beast. So basically the forces of capillarity, it gets into our soils. Oh, and it disappears immediately. It's not going to work. Everyone look the other way. The sand's far too permeable. So it goes in and it moves down the side. Look how quick it's going in. That's amazing. I wasn't expecting that. So that's very greatly disappointing. I have to edit that bit out. Okay? But you can imagine, I used to do it on soil and sand. So let's just do that, because then we will be able to see it. And the image I'm trying to portray here is what? Capillary action and absorption and movement downhill. So downhill is the key point, okay? That's the key factor, because when we're looking at where it's going to go, once we know where it is, and when we're in our bushland trying to work out whether we've got it or not, we're looking at the topography of the land we have. So now, I've just, come across a disease infestation, and I've come across and oh dear, I've got it all over my foot, and I've put it there. And so suddenly we've got that sort of effect. And then, Chris, she loves bushwalking and she's filthy. I don't know if you've ever been to her house, it's revolting. And so she then, gets a dirty shoe and walks it all over there as well. So suddenly, through human movement, we've got not just one infestation that's moved that far, but we've got another one and then another one. And over the period of time, got introduced to Western Australia in the 1940s, we believe. So it's been here now for 80 years. We now have this mosaic, if you like to call it that, of heavily infested and uninfested areas throughout that rainfall zone that I was talking about before, which stretches in the north from just south of Kalbarri right around the coast to sort of Cape Arid and beyond, out to the Eucla, and we'll head inland to that 600 millimetre rainfall zone, and there are still impact sites in the 400 to 600 millimetre rainfall zone. So if you imagine drawing a line from Kalbarri to Cape Arid that spreads inland to places like Mora, help me out here, well east of Northam, right out to sort of Salmon Gums, Ravensthorpe, that whole strip. We've got a very significant area of our primary forest system, coastal heathlands, a range of very, very special environments that we have that are being impacted.
Is it very much with soil type?
Yeah,
But
very different. Yeah. So just quickly while we're on that, in this region we have multiple different vegetation types, largely influenced by our soil type. COVID-19 is possibly the best thing that's ever happened to Dieback information because it gives us an analogy that I can use, that we all really now understand. Because one of the key factors of controlling it is hygiene, but we also need to understand that, you know, I might have had COVID, but I don't really know. My son got it, my wife, we were both in the same house, in the same car, in the same environment as him. Everyone else got it. We both sort of felt mildly crook, tested negative, didn't get it, but perhaps we were just asymptomatic. And a lot of areas, some vegetation types are going to be asymptomatic, but the disease is still there. Others will maybe get a bit of a runny nose and maybe a bit of a dry throat, but won't necessarily feel that crook. Whereas others will, you know, spend weeks and weeks and weeks in bed, and others yet again will just die.
Jeremy,
And-
do you know why the asymptomatic areas are asymptomatic? Is there anything you can learn from that?
Well, so highly alkaline soils. So you're up along the Lewin Ridge and to the west of the Lewin Ridge where you've got limestone outcropping, what have you. It doesn't like the high pH environment. So soil alkalinity is key. There are multiple species of Phytophthora. Phytophthora cinnamomi, which is the one we're going to look at today, is the most aggressive species, but we have other less aggressive species that do persist in the alkaline soils. There are species, the Maori tree right here, we used to call them eucalypts, now we call them corymbias. They're, you know, quite obvious by the big conky nut that you used to be able to throw at your mates when you were 6 years old, and then your mum would hit you. No, I'm still on the story of being hit by my mum. Not then. No, so they're the bloodwoods, and they have an internal structure that allows them to ward off the disease that gets in, and build around any invading sort of beastie and fight it off. So they can actually protect themselves that way. A lot of our acacias, the wattles, the yellow flowered little sort of poof flowers, circular little, you know, pom-poms, thank you. They have a symbiotic relationship with nitrogen-fixing bacteria, which are called... No points. They're nitrogen-fixing bacteria, and the scientific name's just eluding me at the moment. But they, sorry, was that no? Pom-poms. They create an antagonistic environment again that wards off the pathogen. So, for every different species, there's a different mechanism that helps protect them, and soil conditions and soil moisture. So we are looking at specific environments.
What about like a more healthy, intact bit of bush compared, like, because I've seen like clearly in a bush area where upstream it's dieback infested, downstream where it's wetter, it hasn't, the species haven't suffered.
Yeah.
But clearly it would be in there because it's the lowest point.
Yep.
But it is also the healthiest patch of bush.
Yeah, absolutely, Cass. And that is one of the key things. And the same with us. You know, let's keep reverting back to what we are, because we are just another life form. And if you're healthy and if you're eating well and you've got a well-balanced diet and you're not under stress and a cold comes through your community, there are going to be, you know, certain people that maybe have, you know, drink too much, smoke too much, eat lots of macas and chocolate bars, and they're going to be the people that get crook. Whereas the healthier people have a better autoimmune system perhaps, and there is a lot of variation. We're actually undertaking a trial that we're doing on behalf of ourselves, really out of interest, and we're partnered with Murdoch University and the Banksia Farm and DGCA down on the south coast, and looking at seeing if we can actually isolate what it is in certain environments, because you go into Banksia coccinea woodlands and everything is dead except for about 4 different plants. And is it just luck? Is it genetic variability within that individual? So we're sort of running a few trials, trying to develop progeny and then trying to kill them and see if it's what the cause is, to investigate that further.
But some plants are not susceptible.
Some plants are
so
not.
About 40% of the plants
Yeah.
are susceptible, and some just aren't. So down your creek line, you might not have, susceptible species expressing the disease.
Yeah, that's right. And so there are, and a lot of the creek lines do have less susceptible species, but also there are wetter areas, and they're not so prone to drought stress or other things like that. So just trying to regather my thoughts now. Where are we at? What's it doing? The disease gets in and it starts whacking the bush. So as my wife just said, Mary said, 40 to 45% of the species. Can I get everyone to stand up here for a second? So we're just going over in our minds what we've learnt so far, right? So it's a microscopic organism. It likes the conditions to be warm and moist, and it affects about 45% of the species, and it's in the soil and it's attacking our fine feeder roots. So just stand up, make sure you've got a bit of space, and put your arms in the air and you can feel the breeze. And I just need you to wave your arms around, because we're all trees here and we're having a wonderful time.
You're just doing that.
It is what we do. It's got nothing to do with Dieback at all. I just like to take photos and make people look like a bunch of plonkers. And we put them on our Facebook on a different company's page. No, but still, it is quite relevant, because I thought you looked wonderful. I want you all to think of a number between 1 and 10. Okay? Now I'd like everyone who thought of an even number to sit back down. Okay. So now just turn your heads around and have a look at what's happened. So we've lost a significant proportion of plants, because you guys are all species in the bush. We've just suddenly lost a bunch of species, all of that 45% that are susceptible to the disease, and they're all now removed from that ecosystem. So we've lost biomass. It's a word I want to get us to become familiar with. We now no longer have as much living material in the bush, and suddenly we have all this other space. You can all sit back down again or relax. And so why is that important? And there's a range of reasons why it's important, and one is just simply because the plants are dead. You guys sitting down weren't just having a rest. You're dead. Okay, you're not coming back. The marries and the tree species that are not susceptible move into your space. Okay, they put their roots down. And so where we have an environment that had a biodiversity, for example, like the Fitzgerald River National Park, which has, time to redeem yourself.
Oh,
How
more
many
plant
species?
species than the entire UK? Is that what you're...
I want the actual number. I think it's over like 1,400 species, isn't it?
Yeah,
Something
it's
amazing.
It's highly biodiverse.
And lots of those are highly susceptible. And because Australia has been isolated from the rest of the world for gazillions and billions of years, up until we sort of came in and brought Phytophthora and other things to it, they haven't evolved any specific mechanisms to help themselves protect themselves against it. So we've got incredible biodiversity that's really important on a global scale, and a high level of susceptibility, because they've got just no natural defences, no natural manner of fighting our way off from that. So we're losing the plant species. I'm just going to flick a few pictures around. This is a photo of the Jarrah Forest up near Dwellingup. So this is as the origination, if you like, the origin, that's a better way of saying it.
Better word.
I like new words though, I think new words are good. That's the origination of where dieback came in our world. Just pass it around, Peter. And we called it Jarrah dieback because it was getting in and it was hammering the big Jarrah trees, okay? Smashing them in certain areas. And we thought that was really bad because we were making money out of the Jarrah trees and we weren't paying any attention to the fact that all of our understory species were primarily our banksias, our proteaceous species were being hammered, absolutely smashed. The Jarrahs will die, but it's got to be particularly bad. It's got to be particularly hard and they've got to be under other forms of stress to be able to impact them. What's really happening though, and what the early researchers didn't realise, was that it's actually getting into the understory, into this layer, and taking out, that's where the 45% of the susceptible species lies. It's not the one species of tree that sits up in the overstory. But when you start getting impact like that photo of the Jarrah forest, we're also getting the sun suddenly burning straight through, drying out that understory, sun burning our mushrooms, that might be another new word. We have a removal of the shelter, exposure to direct rainfall, erosion. We have exposure to direct sunlight, increased drying. It's changing the whole balance of our ecosystem. And they're the plants. You know, plants don't actually do anything. They don't really actually help us. Who really gives a brass razor? Well, these guys do. Because, you know, this is our native fauna. And I do this session with little kids. And I always talk about, you know, that time you go to the supermarket, you know, you go down, what's your favourite aisle in the supermarket? And they go, oh, I like the chocolate aisle or the ice cream aisle. I go, oh, it's my favourite one too, because it probably is. And it's like, you know, what do you do? You go to the supermarket and you get to the chocolate aisle and whoa, it's like the toilet paper aisle during COVID times. It's empty. There's one pack of chocolates left. So you walk up to the person, look at it, and give them a black eye, grab it, and you run. But then there's nothing. There's nothing left. And these bushland areas are the supermarkets for our natural fauna. You know, it's the black cockatoos. You know, they love these. But they do like a bit of variety. These aren't going to be killed by dieback, but this is all they're going to be able to get to eat. A little honey possum, might even be your fingers, mightn't they? The little honey possum, you know, that little guy loves the proteaceous species, the banksias, the bull banksias, Banksia grandis. We've got sandplain banksias, Banksia attenuata. We've got Benzizii, licifolia. The list goes on. And they're the food source for those guys, and they are the important reasons why we, as the superior race, have responsibility to make sure that, you know, our footprint on those guys is not such that we've taken away their supermarket and at the end of the day taken away their homes. This is a classic example of Phytophthora dieback expression. I'm just going to hold it around, one for the camera. I feel like Bert Newton. This is down in the Stirling Range National Park, and I want you to have a look at the road alignment, and I want you to have a look at the, what am I talking about, the shape of the mountain peaks in the background, the horizon. So this photo was taken in the 70s. So it is a beautiful photo. It is a beautiful photo. And then a colleague of ours went and thought, what a great idea, I'll go and find this same spot. And he went back there about 30 years later and he took a photo from the same location. And you can see, you know, a lot of people go, oh, I bet it was a different season, it just wasn't flowering. But you can see the ground. You can see the way the disease has got in and it's actually, removed the biomass.
The lambertias aren't there anymore. You know,
The
species are different.
The grass tree's not there anymore. Just have a look and pass it around. But one of the issues that we've got, I'm just going to have a mouthful of tea, excuse me. One of the issues we've got with Dieback is that those two photos are taken, what did I say? 30 years apart. The change is like, who's got kids? You know? It's like 19 years ago, my youngest son was born, and he was cute and he was gorgeous, and he made a few, less than cute and gorgeous noises, but he was still lovely. And every day we looked at him and he was always cute and gorgeous. And then suddenly one day he was big and ugly and he smells and he's made off with the car. It's, but where did that time go? It just suddenly, you go for the car keys and they're not there. You just don't notice it happening because it's incremental changes over time. So you go into the bush and people go into the bush and they see what Dieback's doing and they go, oh yeah, so there's a dead plant there. So what? But when it's been in the area for 20, 30 years and it's killed 5 plants a year, and you've got, if you can just still see them, we've got a splodge there, a splodge there, and a splodge there, and they're spreading autonomously, and potentially Christine's going for another bushwalk and she's spreading it here. It's spreading further and further, and so the order of magnitude of change is increasing exponentially, and that's when we do get the demonstration of impact, particularly like that photo of the Jarrah forest where everything has gone. So it's difficult to communicate the impacts to people because when you see it as a one-off snapshot, it's kind of hard.
Can I ask a question? Does fire speed up the process a bit? Because, like obviously the Fitzgerald and the Sterlings have suffered a lot of fire and, I guess you're opening ground up more for more runoff.
Yeah. It has a varied impact. Immediately after fire, there's an ash bed, there's new life, new nutrients, and a lot of the vegetation will shoot up really quickly, and there'll be a refreshing, if you like, and it almost goes away visually. But fire also increases additional stress on ecosystems, opens it up to other areas. We march in there with all good intentions and dirty trucks and can potentially spread it. Fire lasts for a short period of time. Dieback lasts forever. So it does nothing to remove it. That's the first point to get across. Fire does not kill dieback. Dieback's in the soil. The heat goes up, and it has varied impacts, and it can potentially make it worse in the short to medium term because it's increasing stress levels in plants after that sort of short burst.
And if you have frequent fires, the sort of plants that you have in some systems are not going to have time to, mature and set seed again as well.
So we've learnt that it's microscopic. It's in the soil. We can't see it. We can identify it by recognising that it's like a plant's had its throat cut and it's died completely. Very diagnostic key. While it spreads autonomously, we are the primary concern. How are we the primary concern? We get it on our boots and we get it on our cars and our trucks and we move it around. So if you're a landholder or a large-scale land manager or a recreational club, you've got to be able to identify your particular mechanisms of spreading it around and work out where it's going to go. So I get my enormous cup of water, thank you very much for my cup of tea. It spreads down the hill, okay, it spreads down the hill. So there's very little point in putting effort in trying to protect the areas downslope, because regardless of what you do, it's going to become an infested area. So we want to focus on those areas that are upslope of our vegetation where we can actually have a meaningful impact, okay? So you're now trying to look at your areas that you want to manage effectively for dieback, and you want to work out whether they are going to be influenced by autonomous spread or whether they're going to be influenced by human spread, and what you can do about it to stop it spreading. What's the number one key for stopping that impact? What is that spread?
Close it off.
You don't have to close it off.
Hygiene,
Hygiene, what do you mean?
like cleaning boots and bikes and cars.
Cleaning boots, bikes, yep. Or, and if you don't like cleaning,
Putting it in the bath.
putting it in the bath. One of the easiest things, okay, so it spreads in mud. I'm going to get a bit of mud on my shoe, okay? And I've failed, really. It's dry soil, okay? So if we're looking at operating in a protectable areas, so go back to the failed sand pie. If we've got a disease edge around there and all of that land is infested, and we saw how it spreads downhill, then this area up here becomes our uninfested and protectable area with lovely green vegetation on it. But that's our protectable area, so we want to make sure that any activities we're undertaking in there, we undertake in dry soil, because we don't need to, it's very unlikely we're going to spread anything in there. If that's our access path, there's another access path for the people on this side, then we want to make sure when we cross that disease edge or that barrier, we want to make sure that we don't have any dirt or infested material on us when we go into this zone. Remembering that it might take us a couple of hours to clean our car or the trucks or whatever it is that are going in there, but once it's there, we've seen the pictures of what it does, and it keeps doing that over and over and over and over again. So if we are looking to manage a protectable area, then we want to do what we can to make sure we keep it protectable and take the effort. How do we do that? First of all, you've got to get your area mapped. So the other thing we're starting to look at, we didn't put our green and white red sign in.
Oh.
Never mind. You guys didn't deserve to look at it anyway, I didn't. Sorry, that was rude. So this is the green and red. Green is the colour of bush. It's healthy vegetation. So we map everything. A dieback interpreter will walk through the vegetation in lines. I don't know if you can tell, but they're roughly straight lines. We walk through the bush, walking 50-metre transects, recording data of whether the bush is infested or not. That gives us a picture of where the disease is. We then bring that evidence data of what we're seeing home. We put it into a GIS program and basically remove that, and you just get a map that shows you green is uninfested, red is infested, and there is another colour, which is purple, which is where the vegetation is not susceptible, so we're unable to determine whether it's there or not, and that's sort of an intermediary category where we apply the precautionary principle and limit access in a specific manner.
How frequently is the mapping happening?
The mapping is happening across the state continuously. We did this project not that long ago.
So like every 2 years you go back, or to see
Depends.
change?
So it depends on what your activity is. So if we go back to our sandcastle here, if you've had this area mapped and that has been deemed to be protectable, then and no one goes into that area, and you don't have any soil moving operations such as road grading, construction works, any recreational activities that potentially do that, then the autonomous rate of spread upslope is about 30 to 50 centimetres a year. So you really don't need to worry about your mapping again until you're going on to undertake some sort of activity that needs to know what that data is. You've just basically said all of this area is unprotectable or infested. we're going to manage that without activities. We can undertake our activity in a protectable area and move on. So it's horses for courses as to how often you want to do it. I'll pass these around as well. You can have a look at those. The little red dots are where we take a sample point. Try to get it back actually. You'll also see, sorry, an Indian viewer. The red has black hatches on it, and there's a couple of areas of green that also have black hatches on it. Now those areas of green are uninfested, but the black, green spots are. There are evidence. So that's where we've gone through and we've found that we've got uninfested vegetation, and you'll even see green spots in some of the red areas. But that's where we've come in and we've got a very small spot of uninfested vegetation that's in the bush, and it's but it's surrounded by infested everywhere, so we can't really manage it and we can't do anything. It may just be a small spot of asymptomatic plants, so we just manage it as. The black hatching on the green areas are where the area is either too small or it's an uninfested area of vegetation downslope of red, so it's going to spread that way. So once you've got that and you've got your information, you now know what you're trying to do. What are you trying to manage for? Are you trying to protect the aesthetic values of your bushland so that visitors to your site are coming? Are you trying to do it because the state government has said we're only going to approve your project if you do this? Are you applying hygiene? So in those situations, we would apply hygiene. They will plan their operation so that they avoid the green where possible. They will only go into the green areas during dry soil, and on the edge of the green and the red, which is that line between the top and the bottom, the infested and the uninfested, when they get there, they get to that line and they go, I need to do a clean down, and they clean themselves down. We saw clean down when we came in through the gate there. So clean down can be wet clean down by sterilisation. Clean down can be dry clean down by physical removal using a hand brush. It can be physical removal using any range of tools depending on what you're cleaning down. And it's becoming more and more important. Okay, we may have noticed when we came in through the main gates here, they've got farm biosecurity. That's not just for Phytophthora dieback, it's for a range of other issues. Phytophthora, for example, Phytophthora infestans was the pathogen that took out all the potatoes in Ireland and half the country starved. There are a range of Phytophthora that do a range of things. There's a range of other of weed species, of insects, of various types of pests that all get controlled by hygiene. Hygiene for dieback is removal of soil from boots and machinery and that sort of thing. If we are looking at protecting our aesthetic values, so we have an area that has been infested and it's right in front of our cellar door, or it's right in front of our front yard, or we've bought a beautiful bush block and we've brought in, a contractor's made us a lovely gravel driveway right to the top of our hill, which is glorious because it also helps us get to our house, but it also brings in dieback, and in lots of areas around here I've seen exactly that. People have bought a beautiful bush block, introduced dieback on the gravel driveway, and now they're going, oh my goodness, it looks like that Jarrah photo that I passed around. So they have undertaken research into what Phytophthora can be treated with. This is a phosphite product. Phytophthora does not just impact native vegetation, it impacts avocados significantly, it impacts the citrus industry, it impacts various nut, call them orchards, your azaleas, your roses, they can all be taken out by Phytophthora. our native plants have evolved in very nutrient poor soils. They don't like nutrients. Phosphite is effectively a phosphoric product. It is, in a way, a type of nutrient. And so because our natural environment has evolved without too many nutrients, we use incredibly small doses. The process of stem injection, so we can actually remember how the plants work. When I first started prattling on, I was talking about phloem and xylem, and photosynthesis and the movement of everything inside the inside the plant's cambium. So they actually have an injectable system, thank you, just like we do. So we can actually drill a hole into the side of a tree and inject it, and they will actually take the phosphite up, and that will transport it in the internal transport systems up the leaves, down to the roots. The phosphite's impact on the tree is that it helps thicken up the individual cell stems within the plant and stimulate the autoimmune system. So it probably has a few benefits for other pathogens, but it has actually been shown to have a positive impact on treating infested plants. And I've actually seen it in the bush. I've been up undertaking dieback surveys in the Shire of Busselton on the strategic firebreak areas, and I was walking around this area once, and you'll get a better understanding of what I'm talking about when we go and have a look at dieback. But I'm wandering around, I've been doing this for 20 years, no one can tell me about boats, I know everything. And I'm walking around thinking, geez, I don't know what's going on here, what the hell is happening? And then I found out that one of my colleagues had been undertaking a treatment program in this vegetation, so while it looked like it was infested to me, it was actually fighting off the disease, and the treatment was actually having an impact. So, basically, we undertake the program by filling up your syringe. So, are you James?
Yes, I am.
Mind if I drill a hole in one of your trees, mate?
Go for it.
Fantastic. So, we undertake the treatment by filling our syringe with dieback. I'm just going to whack it into... I'll do it on the walk because there's some better ones just up there. So we'll whack it in and we'll have a quick look at how it goes in. And it actually takes the juice up into the tree over a period of maybe, half an hour to a couple of hours. We've got hundreds of these syringes. We'll go through an area and we'll leave them all injected into an area, and it'll take most of a day. These sorts of things, I do believe, there might be a couple of resources within the local shires.
And we do. Yes, we've got dieback kits here.
Yeah. Oh, with the treatment.
Yeah.
Fantastic.
Yeah. So we've got the phosphite.
Yep.
And we've got the syringes. We've got a little bit of information on how to do it, and you can borrow it from us.
Fantastic. I'll grab those maps. So now, when you leave here, you should be armed with the ability to at least get some sort of understanding of what you're looking at and what you're doing. And when you're undertaking a treatment program, you want to look at those red and green edges, and you work your way around that red and green edge. If you've got unprotectable areas in here, this stuff can form your protection, so you can actually assist these areas. And if you may have specific natural assets such as threatened ecosystems, threatened susceptible species in communities that are under threat from dieback, then you can target them as well. So the way you apply your treatment program is very specific to your individual objectives and desired outcomes. But if you're working a large disease edge, we just focus on that interface between the red and the green. So again, you want to have that ability to be able to roughly map where your dieback is and then work along it. So again, we basically inject all the trees, to about 2 to 3 centimetres. Now we talked about the xylem and the phloem, or the vascular tissue. It's the cambium, it's just under the bark. Depending on the size of the tree is how deep it goes, between 2 to 3 centimetres. And you can see the colour. When we drill a tree, you can see it. It's white and it's soft and it's fleshy. So if you're drilling in and you're getting dry, browny sawdust, have a look up. The tree's probably already dead. It's not going to take anything in. But living trees have those sections on them as well.
Can I just ask, is there a point at which, if a tree is looking pretty unwell, that it's just, there's no point in doing it?
There is, but again, an individual tree is like an individual person, and we all have our own, you know, our own. So I usually stick them and give them a chance anyway, you know.
How long does it last for before you need to do it again?
Okay, so again, all environmental systems are unique. You have different soil types, you have different rainfall levels, and they influence your rate of growth. The faster they're growing, the less time it lasts. The stem injection lasts between 3 to 5 years. And the foliar spray, which is done at a lower concentration because again the nutrients can result in leaf burn. The foliar spray is between 1 and 3 years. So we are a contractor that undertakes treatment for a lot of the local governments in Perth. They've sort of got a mid-range time frame of every 3 years we go through and do spray and stem injection across their areas. An important point just entered my head and then quickly shot out the other ear then. I can't remember what it was. So if it comes back, yeah, I'll let you know. But yeah, no, I can't remember what it was. So I think now probably what we want to do is wander up here. We're going to go we're going to walk up the road about maybe 100, 150 metres. I'm going to introduce you to all of the susceptible species, because that's key. You really need to know what you're looking at and who you're looking for, because then once you start to be familiar with the susceptible species, you then are able to identify the way they are dying and become dieback interpreters, able to work out whether or not you're working in an infested area. So I'll just fill up another syringe or two and we'll wander off.
Jeremy, while you're doing that, can I ask whether, from what you described earlier, it goes from here to Cape Arid. So is it a WA disease predominantly?
No. So we also have Phytophthora pneumoniae in Tasmania and New South Wales. It's an introduced pathogen from Malaysia, we believe. It's just we have incredibly susceptible species and highly conducive soil conditions over here. So it's far more impactful in our environment.
And what it seems like, what you're suggesting is like applying a lot of band-aids all across. Is there some more profound research happening at a larger level to fight the disease?
Unfortunately, plant diseases and environmental diseases, in my opinion, just don't get the respect they deserve. Because it's not impacting us directly. So WA is pretty much the epicentre of Phytophthora pneumoniae research, and that was primarily driven by its impacts on the Jarrah logging industry. So I would say broadly your answer there is no. They have undertaken research programs. We have eradicated it in certain areas, but the nature of the eradication program is so destructive and so full on, it's pretty much nuking sites, and you're not just killing Phytophthora dieback, you're killing absolutely everything that exists in that area. And we see areas that are infested that are multiple hectares, as in hundreds of hectares in size. You just cannot feasibly apply either the band-aid of treatment or the eradication to those scale of areas, just because of.
So is there any organisation really making it its mission to to address this big challenge? Who's the leader?
I've just remembered what came into my head before. My business cards are over there. It's not my email address. I am not the leader. I am just a source of information. I'm a mouth on a stick. But if I say anything that you want some information for, then you can email me, and I'm always happy to email the Dieback Working Group, dwg.org.au. Might even be Dieback Working Group. I don't know. It's not my website. But if you email me, I can send you a link. They've got a range of resources, a range of documents on how to handle it, how to treat it, how to manage it, and they are pretty much the organisation that has at least resources and links to other.
They produce that.
Yeah.
In terms of, gravel being one of the big spreaders,
Yep.
going out on roads, is there now regulation over gravel suppliers, for example, that they need to be providing clean gravel or treat, if you're saying you nuke stuff, if they a gravel pit, then that's okay because it's a gravel pit.
So the main roads are actually taking a bit of the lead in this space, and they're treating gravels with metham sodium, which sterilises it, and they use that in high value locations. So they're not using it everywhere, because if you think about the example with the protectable areas, most of their road alignments and road networks are what we deem unprotectable because we have uncontrolled usage by all of us and all of our mates, and there's no control over them. But they do treat gravel with metham sodium and sterilise it. But the issue with clean gravel, and if anyone is told you have a gravel supplier that has certified dieback free gravel, just poke them in the eyes, call them a liar, shove them away and go to someone else because it cannot be done.
Can you use limestone instead?
Limestone is much better for Phytophthora cinnamomi because it has that high pH. It can bring in Phytophthora multivora and Phytophthora nicotiana, which have a far reduced level of impact. So it is by far and away the beneficial method. Absolutely. But again, what we're doing is identifying, where are my maps, our protectable areas, the green areas that are upslope and don't have the black hash on them. We're identifying our protectable areas and saying they are our assets, they are our resources. These are the areas we're going to focus our energies on protecting. So these areas here. So we're going to say this is our management area here. It's green for uninfested, healthy vegetation. We're going to go into those areas only if we need to, only in dry soil, and we're going to undertake vehicle inspections and place hygiene stations around the boundaries so we know where we are before we go in. We're not going to waste our time trying to protect and manage road alignments, fire breaks, places where we have unauthorised, uncontrolled, unmanageable access. Okay, so happy to take lots of questions. Let's wander up here. We have a dieback infestation in here, and just on the edge and above it we have a very good example of a Jarramari woodland over a Banksia grandis, bull Banksia woodland, mid-story, over a sort of a low sedgy heath with xanthorrhoeas and a bunch of other species that are susceptible. So we're going to have a look at how this area is expressing, how it's showing the dieback. We're going to learn to recognise the dieback, pick what it's doing, and then work out where we're going to apply our management and that sort of thing. So let's wander up and have a bit of a